Hi, welcome to our video on the law of cosines. And this is actually something that I guess we used in the last video where we solved a trig word problem. Now, basically the idea is that you can use cosine even when you don't have a right triangle, right? When you have a triangle, whatever, looks like this perhaps. Well, this is not a right triangle, right? Let's assume it's close to it right here. This is not a right angle, so what do we do? Well, let's talk about that. So let me first set it up over here. So we want to give names to every side. Let's say down here, this long side, what's this going to be? Well, let's say this is x, right? And over here, we have y, and over here, we have, I don't want to say z because my z's always look like 2's. So let's say a. Okay. So we have x, y, and a. And let's say we're given this angle right here, theta. Okay, that's my theta. And I want to know a or something. Well, how do I do that if it's not a right triangle? Well, the first step really is to think about dropping it perpendicular so that we have two right triangles. Right, to create those two right triangles, and then we can kind of work our way from theta over to A. Now everything I'm about to tell you, of course you can memorize if you have a quiz or something, but really you're not going to remember this many years from now, so you should be able to have the confidence here to work from some simple principles to figure out what the law of cosines is, which is basically saying that I can use this angle to get this side, or if I know these sides, I can find the angle, right? I can use any three of these variables here to figure out the other. And that's pretty cool. So anyway, what do we know? Well, the cosine of theta is going to be the adjacent over the hypotenuse. And already I'm starting to work my way over towards A. So the cosine of theta is the adjacent side here over the hypotenuse. And what's the adjacent side? Well, we don't know yet. The hypotenuse is y, so we need a name for the adjacent side. Let's call it r. Right, so that's r. So it's r over y. That's what the cosine is equal to, is r over y. And so that means then that r is a distance. It's always going to be equal to y times the cosine of theta. And that's what r is. We're going to leave that as this little length r. And we want to know what a is, right? So we're going to work our way over. So what is this distance right here? Well, we can call it anything we want. Let's call it C. What is, we can't see that. What is C equal to? Well, C is equal to x, the total distance, minus r. So C equals the total distance on the bottom here, x, minus r, that little piece that we just looked at. And we already know that r is equal to y times the cosine of theta. So C is just x minus y cosine of theta. And we're almost there, right? Now all we need is this perpendicular line right here. Because once we have that, you can see this is a right triangle right here. And we can use the Pythagorean theorem. We can use this red side and this purple side. We can use C, and let's call this P for the perpendicular, right? Those legs squared to find out this A, the hypotenuse. So how do we find out this perpendicular? Well, let's go back to the original angle. Right, that's our goal, to use the angle and some side lengths to find any missing side. Well, we want to use the sine of theta, because the sine of theta is the opposite side over the hypotenuse. So it's going to be P over y. And that's what sine of theta is. But I want to know what this P length is, so I can use it to find A. So I'm going to rewrite this as P equals y times the sine of theta. And all I did right there is multiply both sides by y, right? Because P over y times y is just P, and then y times the sine of theta is y times the sine of theta. It's exactly what I did up here, but just with different variables. Multiply both sides by y. R over y times y is just r. Those y's cancel out. And then y times the cosine of theta is what we have over here. So now we know that C, what is that? Well, it's always going to be x minus y cosine of theta, and P is always going to be equal to y sine of theta. So if I want to know A, I'm going to use the Pythagorean theorem. I'm going to square Whereas I want to square p, and I want to square r, and add them together. Excuse me, I want to square p, and not r. R is over here. I want to square p and c, right? These two sides. So I'm going to circle c, so I don't forget that. So I'm going to square c plus p squared. It's going to equal a squared. And we'll write that right over here. C squared plus p squared is going to equal a squared. That's the Pythagorean theorem. So c squared is just, well, x minus y cosine of theta squared, plus p squared is y sine of theta squared. And I'm going to simplify this one over here. It's going to be y squared sine squared of theta. That's going to be this piece right here. And next we're going to deal with this. All right, we're going to expand this. So that's x minus y cosine of theta. I'm going to show you how to expand this times itself. It's because it's squared. X minus y cosine of theta. And then plus what we had before, which is y squared sine squared of theta. All right, what do we do here? Well, we are going to distribute these two terms, right, and multiply them each by each of these terms. So x times x, what's that? It's x squared. Next we have x times minus y cosine of theta. So we think of that as minus xy cosine of theta. But let me move that over because I want to make some room. We're going to do that twice. Next we're going to do y cosine of theta times x, which again is minus xy cosine of theta. So we have 2, right? 2 minus xy cosine of thetas, and then lastly negative y cosine of theta times negative y cosine of theta is positive y squared cosine squared of theta, and don't forget to add this back, plus y squared sine squared of theta. Okay, now what? Well, what's always going to happen now is that you can pair up these two terms and factor out the y squared, so it'll be y squared times cosine squared of theta plus sine squared of theta. And that's nice because one of our trig identities is that the cosine squared of any angle plus the sine squared of any angle is just 1. So this is y squared times 1, which is just y squared. And I am running out of room, so let me copy this and make a new page because we definitely need the room. But we're almost done, so hang in there. So right now we're up to this, right? And we said that this is 1 times y squared, so let me rewrite everything so that we have x squared minus 2xy cosine of theta plus y squared times 1, which is just y squared. So y squared plus, well, x squared minus 2xy cosine of theta. I'm just going to rewrite that. So we have these two terms together. So it's x squared plus y squared minus 2xy cosine of theta equals what? Well, that equals the hypotenuse squared, which, how did I write that? That was a squared. So c squared plus p squared will always equal a squared. So that means that all this stuff right here, which was c squared plus p squared, is going to equal a squared. And there it is. That's the law of cosines. Now, again, you can see why this is not easy to memorize. I mean, look at this thing. And in fact, you might see it written as with a's and b's and c's. You might see something like b squared plus c squared minus 2bc cosine of theta equals a squared. Same thing, different variables. I usually avoid b's though because as you can see my b variables look like 6's. But what this means is that in this equation, if you had an angle and then 2 of these sides, right, if you had cosine of the theta and then b and c, you could figure out exactly what a was. Or some other combination, right? If you had a squared, or if you had a and you had the cosine of an angle and you had c, you could figure out what b was. So you can use 2 legs and an angle to find out another leg. Or if you had all the legs, if you had a and b and c, you can use this equation to figure out the angle of cosine. And that's pretty powerful, right? Go back to our original diagram. if you had this angle and then two of these sides, you can figure out the other, regardless of what the triangle is. And that's the law of cosines. It takes us beyond the right triangle. It allows us to use theta and trig to find side lengths for any triangle. And that's pretty cool.